Okay, so this should be the final video covering activity 5.7 and 5.8. We're going to continue to solve radical expressions, or equations, excuse me. So we begin with example 4. So you notice we have this square root of x plus 3 equals x plus 1. So again, our first step is really to free the variable that's underneath the square root sign or the radical sign. So we can do that by squaring both sides, right? That's really our step number 2. So you see they square both sides and end up freeing the x from under the radical sign. Right? So now we have to solve the equation. Well, what's left? Okay, so if I subtract x from both sides, that's a good start. Right? That's going to leave me with 3 equals x squared plus x plus 1. And then if I subtract 3 from both sides, we'll have 0 equals x squared plus x minus 2. Right? This is a 3. Okay, so this, we know how to do this. This is basically factoring a trinomial, right? We have 0 equals, and this is where we ask ourselves what two numbers, when multiplied, result in the last term, right? I'll do a little table up here. The last term is the negative 2, and the middle term is the positive 1. That's coming from here, right? The negative 2 and the 1x. Right, so how do I get negative 2? I'm guessing, I guess, negative 1 times positive 2 would give me negative 2. And when I add these together, I get 1. So I'm going to write x minus 1, x plus 2. But that's not my final answer. We have to solve this thing, right? So the values of x that will give me 0 would be positive 1 and negative 2. Right, these are my two answers. Okay, now we have to, according to step 4, we have to check our work. Okay, so I have to plug in or substitute the x equals 1 and the 2 into x here and here. Okay, so let's do the check. We'll start out with 1 first. All right, so I'm going to write the square root of 1 plus 3 equals 1 plus 1, right? That's me doing this check up here. All right, so we end up with the square root of 4 equals 2, and the square root of 4 is indeed 2, so this checks out. So x equals 1 is a good solution. All right, now let's try x equals negative 2. All right, so I have the square root of negative 2 plus 3, and I want to set that equal to negative 2 plus 1, and looks like we have the square root of 1 equals negative 1, and that's a problem, right? The square root of 1 is 1, and that does not equal negative 1. So x equals negative 2 is an extraneous solution, okay? This one is extraneous. Right? Let's say x equals 2 is not a solution to the original problem, okay? But x equals 1 is. So I'm going to write x equals 1 as my solution. Then it does say, listen, we can do a quick check graphically, so let's give it a shot here. All right, so I open up my calculator, and y equals, I enter x plus 3, the square root of that, and I enter x plus 1, right? That's the right and the left side of the equation. Right? Again, that's coming from up here. Square root of x plus 3 is my y1. X plus 1 is my y2. All right, wonderful. So when we graph this, I'm going to use a standard window. So I'm going to press zoom 6. And we're looking for the intersection. And you'll notice there's only one intersection, right? We don't find two intersections, and I'm guaranteeing that this intersection is going to happen at x equals 1. Second, trace, 5, enter, 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 and I get an intersection at 1, 2, right? So x equals 1 is a solution, and you'll notice we were wondering, is x equals negative 2 a solution? And if you go to negative 2, you'll notice there's no intersection. Okay, so x equals negative 2 is not a solution to the original problem. It's extraneous, okay? So let's squeeze in a practice problem or two. If we look at practice problem 19, my first step will be I'm going to add the square root of 6x minus 18 to both sides. Right, so I add the square root of 6x minus 18 to both sides. Let's put that over. There we go. So we're left with the square root of 2x equals the square root of 6x minus 18. If we square both sides now, you're left with 2x equals 6x minus 18. And then we can subtract 6x from both sides. I'll write my result up here. And I have negative 4x equals negative 18. And it looks like I'm left with x equals negative 18 over 4, which I guess reduces to positive 9 over 2. Okay, so it looks like that's 4.5. So I guess we can check our work by placing 9 over 2 into the original equation and seeing if that works. Right, so if I write the square root of 2 times 9 over 2 minus the square root of 6 times 9 over 2 minus 18 equals 0. Okay. So here the 2's are going to cancel. I'm left with the square root of 9, which is 3. Minus, let's see, here the 6 and the 2's going to cancel to leave me 3, which would be the square root of 27 minus 18 equals 0. Right, because 6 times 9 is 54, divided by 2 is 27. And this looks like it's actually going to work. Right, 3 minus the square root of 9 equals 0. So 3 minus 3 equals 0. This then checks out. Right, so the answer x equals 9 over 2 works. Okay, I didn't think it was going to work, to be honest with you. Look at number 20. If we square both sides right away, right, you end up with x equals 5 minus 4x. If I bring the x over, the add 4x to both sides, you get 5x equals 5, or x equals 1. We do have to check our work to make sure this works by plugging the 1 in there and there. Okay, let me just erase some of this other material. So 21. All right, so listen, you see how they use the 1/2 sign? Remember from chapter 2 that raising something to the 1/2 is the same as taking the square root. So, you know, we can leave it as 1/2 and divide everything by 3. You're left with t to the 1/2 equals 7. Now watch what happens. If I square both sides, isn't 2 times 1/2 the same as 1, leaving me with t to the 1 equals 49? Right? I still square both sides, and it still looks like it's going to work out. So you're left with t equals 49. Now let's check this to see if it works out. 3 times the square root of 49 equals 21. Now you might say, why did I write this radical sum? Remember, just as an aside, right, 49 raised to the 1/2 is the same as the square root of 49. Okay, and you know, we've done this already, but if you wanted to just check to verify what I'm saying is correct, right, here's 49 raised to the 1 divided by 2, right, 49 to the 1/2. I press enter, I get 7. If I were to enter square root of 49 and press enter, you see what I'm saying? So 49 to the 1/2 is the same as the square root of 49. So that's why instead of writing to the 1/2, I wrote the radical sign. Okay, so you're left with 3 times 7 equals 21. 21 does equal 21. right? So it checks out. All right, so t equals 49 is my answer. That's it. I think we finished.